For several years, Elizabeth Bjork and her colleagues have been researching how to get students to learn more effectively. They've been specifically interested in the process called encoding. Encoding is what happens when you first try to understand some new material. You might be watching a lecture or listening to a podcast or reading a book. Anything entering into your long-term memory is said to be encoded. But instead of telling students how to learn more effectively, Elizabeth Bjork designed an experience that changed how students encoded what they read. Now, to explain her research, I want to run a 5-minute experiment right now. In about a minute, I'm going to put a series of words on the screen, and I'm going to ask you to remember as many of those words as possible. Now, don't write anything down. This is just between you and your brain. Some of these words are going to look like the words you read all the time, like this. We would just try to remember orange in this case. Others are going to look like this. They're going to have little blanks in them. In this case, we would try to remember the word banana because it's the only English word that fits the information that we have. We're going to do a couple of things after this, and I'm going to tell you more about this experiment when we're done, but I've got the timer set for 60 seconds. Let's go. Now that we're done with that, I am going to teach you a fun little mental math trick. This is an important part of the experiment too, so don't skip it. Say we wanted to multiply a number like 32 by 11. Now the trick to doing this is to take the first digit, which is 3. That's going to be the first digit of our answer. For the second digit of our answer, we want to add the 2 digits of our original number together. So that's 3 plus 2 is 5. And for the last digit of our answer, we just used the last digit of the original number, which is 2. So the answer is 352. Try to multiply 11 times 34 using this trick. Well, that's 374. Okay. Now try to multiply 72 by 11. Okay. That's 792. Now try to multiply 87 times 11. Oops, we run into a problem, right? Because 8 plus 7 is 15, and that's too big to fit into that 1-digit spot in the middle. No worries, all we have to do is to carry that 1 into the hundreds place, so that 87 times 11 becomes not 857, but 957. Let's try doing that one more time with 65 times 11. Right, that's 715. Okay, back to our words. I want you to pause this video in about 10 seconds and try to remember all of the words from earlier that you can. Now you can use a text file, you can use a piece of paper, either way is okay. Give yourself a couple of minutes to make sure that you've pulled everything out that you can. And we're almost done. Now I'm going to display all of the words that I asked you to remember earlier. The words on the left side were the words without blanks. The words on the right side were the words with blanks. Count up how many words of each kind that you got. You can just ignore anything that you remembered but wasn't actually on the list. Now, if you actually did this whole experiment, congratulations, you have become one of my favorite viewers. Thank you very much for participating, and I want you to write down your results in a comment below. I'm going to pin a result which I will update with the average results of everyone who commented, as well as some other basic statistics. But I can tell you ahead of time what we will probably find, presuming that we all did this correctly. You probably remembered more of the words that contained blanks than the words without blanks. This phenomenon is one of the most replicated findings in the psychology of learning. It's called the generation effect. We remember more when we have to generate what we are trying to remember than when we just have to read what we are trying to remember. Elizabeth Bjork used this idea in a very clever way. Instead of just asking students to remember words, she had students read passages from psychology textbooks. In some cases, the sentences looked like normal, like this. But in other cases, the sentences would have a word with some blanks in it, like the ones we saw earlier. So in those cases, the student has to figure out what the word is to understand the meaning of the sentence. Later, these students were tested on their knowledge of what they read. Which sentences did the students remember better later on? Well, just like with our word list, students remembered the sentences where they had to generate a word better than the sentences where they didn't have to generate a word. There's nothing surprising here. This is just the generation effect. It's been demonstrated a million times. The important step is what she did next. In the first version of her experiments, students got to look at their results. Wow. I remembered a lot more of those sentences with blanks in them than the sentences without them. Then Elizabeth Bjork ran the same experiment with the same students. New passages, new sentences, some had blanks, and some didn't. She literally just ran this experiment, so we know what the results should be, right? They should remember the sentences where they have to generate words better than the sentences where they don't have to generate words. But that is not what happened. In the second experiment, there was no generation effect. Students' memories for the normal sentences, the sentences that didn't have any blanks in them, improved to the level of their memories for the sentences that did have blanks in them. In other words, the students just learned how to read more effectively. They were applying generation-like skills to normal reading passages. Why is this happening? Well, Bjork and her colleagues tested a bunch of different ideas. Do students need to have the subjective experience of generation, or can they just be told what to do? Do students need to notice the beneficial effects of generation to improve in the second round? Does the improvement only last for a few minutes, or is it a longer lasting effect? Short delays that they incorporated into these studies didn't disrupt the effect, so it seems longer than a few minutes, although how long it is a little unclear. And remarkably, students didn't have to notice the results that showed that generation was more effective. After a series of experiments performed over many years, Elizabeth Bjork came to the following conclusion. It seems like there are two important factors driving the improvement of learning in that second round. First is having some experience with generation as an encoding strategy. It wasn't enough to just tell people to do something different. A sentence like this one forces you to use a generation-like strategy to understand it. Getting experience with different encoding strategies seems really important to improve learning more generally. The second thing is that knowing what kind of test you are going to be taking informs you about what kinds of strategies are going to be effective. This is one of the benefits of taking practice tests. And here I'm not just talking about tests in school. By test, I mean any kind of experience that actually challenges you to perform the task that you are training to be able to do. Elizabeth Bjork used fill-in-the-blank tests as her outcome measure in these experiments. A generation strategy is particularly well suited to this kind of test because you have to pay attention to the context in which this word appears. Just seeing what this test was like helped to move some students to use a more effective encoding strategy. The larger point here is that if you want to get better at learning, you need to experience a wide variety of encoding strategies. I've got a video that I'm working on now that talks about every encoding strategy that I'm aware of. And you need to get experience or knowledge about how you will be applying what you are learning in the future, which helps you to choose more effective encoding strategies. That's it. I hope this was interesting and or helpful. I will see you next time. Thanks.